Hi, welcome back. We're going to continue our discussion on applications of partial derivatives, and we're going to take a look at another economic application, one that we call the utility function. Now, utility is a measure of utility derived by a person from the consumption of different products. In other words, it's how we use a product. So we could have two different products. For example, we could have an iPhone or we could have an Android. And we want to find out its utility, or how people kind of used it. So suppose the utility function is u equals 5x squared minus xy minus 3y squared plus x plus 2y. Now, marginal utility, now this is what we're going to look at today. So marginal utility of a product is determined as additional consumer gains from consuming one more unit of a good or service. So if this is kind of a fancy word. In other words, saying if I use just one more of that product, how will I like it, or how will it be used again in the future? But the phrase one more talks about it's a change. I am increasing my use. And in calculus, anytime we see the word change, we are always thinking of a derivative. So when we say one more unit, we're saying I want to use this one more. I want to change my use to make it used one more time. So this will help determine how much of an item a consumer will buy. So we want to find the marginal utility of product X. So if I want to find the marginal utility, that is my partial with respect to X. So I want to find u, the partial of u with respect to X. And that's not hard to do here. If I find the partial with respect to x, that's going to give me 10x minus y, and then plus 1. All the y's just go to 0, so plus 1. So this will tell me how much, this will determine how much more of product x I might buy. Determine the marginal utility of product y. So now I want to find out, how can I find out how much more of one item I will use of product y? So that's uy. And take the derivative of u with respect to y. This just becomes negative x plus 6y plus 2. So the next question, now we're going to find out what the marginal utilities actually are. When x equals 2 and y equals 3, should a person consume one more unit of x or y? So now I want to find out their partials at the point when x is 2, y is 3, and I can figure this out. This is just going to become 20 minus 3 plus 1. So that's 17. 17 plus 1 is 18. Uy at the point 2, 3, negative 2 plus 3 times 6 is 18 plus 2. So that gives me 16 plus 2, which is 18. Oh, that's kind of unfortunate that they both turn out to be the same. This is what happens when a math teacher makes up a question. All right, so in this case right here, does it really matter which one we consume? No. So they are both equal, so it does not matter. Both are the same. Both have the same usefulness. Both have the same marginal utility. Now, let's change this up a little bit. Well, what if, imagine if this were not 18, but let's imagine this was 16 instead. Well, now which one would we use? Well, even though these are both really good marginal utilities, y is higher than that of x. So if this number was 16 and this was still 18, we would choose product y over product x. Right. Now the next question says calculate maximum utility. That should be familiar to us. Maximum utilities. So to get the maximum utility, this is where we set the derivatives equal to 0. So I would say u of x equal to 0, u of y equal to 0. So if I set u of x equal to 0, we would get 10x minus y plus 1 equals 0. Y equals 0, negative x plus 6y plus 2 equals to 0. And let's see here. This would give me 10x minus y equals negative 1. This would give me x minus 6y equals 2. And all you have to do is solve this system right there. And I'll let you guys go and do that, or I can just plug in or just solve it. So just solve that system, and you will be able to determine the maximum utility. All right, so let's take a look at cars. How can we do this with the cars? So let's see here. So many pages of notes today. So let's try this one. The profit for selling cars and trucks and SUVs at a local car dealership is modeled by the following function. Profit, cars, trucks, SUVs, CTS. C over T plus T over S plus S over C. We want to find the profits with respect to just the cars, the profits with respect to just the trucks, the profits with respect to just the SUVs. So we're going to find out those derivatives. So that's the first one, the partial of f with respect to c. So be careful. First one is really easy. That's just 1 over t, because t is a constant. This is like saying 5 over x over 5. So we're just going to get 1 over t. That becomes 0. There's no c in here, so it's just 0. So I'm going to go minus. Now we'll see why we do it a minus, because this is s over c. Remember, c is to the negative 1 if I bring it to the top, and we should get negative s over c squared. Now I'm going to write this as a single fraction. My common denominator, tc squared, and I get c squared minus s times t. There we go. So this is the partial profit with respect to cars. In other words, how does our profit change if we only change the number of cars? And that's what we would have. So let's find the change in profit with respect to just the trucks. So same thing, c is my constant. This is like saying t to the negative 1. So we would get negative c over t squared. There's my t right up here. This has no t, so it's just 0. So this becomes plus 1 over s. And again, I want to write that as a common denominator. So I would get t squared s, cross multiply negative cs plus t squared. And then the profit, the change in profit with respect to just the SUVs. Again, this is just 0 there because there's no s in there. This is 1 t to the s, ts to the negative 1. So we get negative t over s squared. Remember, the derivative of anything 1 over x is just negative 1 over x squared. This has an SO plus 1 over c. And if I write this as a common denominator, s squared c, we get negative tc plus s squared. There we go. And the next question says we want to find out when are all these equal to 0. So basically, like if we want to find the maximum profit, how would we solve it? So we just set all these equal to each other and equal to 0. So we would get c squared minus st over tc squared equal to negative cs plus t squared over t squared s equal to negative t c plus s squared over s squared c equals to 0. Denominators don't matter. We're just going to multiply everything through by those. They just cancel out. So we just get c minus st equal to negative cs plus t squared equal to negative tc plus s squared equal to 0. And you can solve it if you ever get bored. All right. So the next question, now we're trying to talk about kind of like that marginal. What if we build a certain number of cars, trucks, and SUVs, and we want to know how we should change the production? So we build 1 car, 2 trucks, and 1 SUV. So that's how many vehicles we build. We're going to build 1 car, 2 trucks, 1 SUV. And we want to change production amounts for the number of cars, trucks, and SUVs you are building so that the profit will increase the most. So we're talking about increases, so of course we're talking about a derivative there. So we're going to be using our derivative. So how can we change the number of production of cars, trucks, and SUVs in order to maximize our profit? Basing your answers on these following values that we found at the point. So now we're just going to find the partials with 1 car, 2 trucks, 1 SUV with respect to our partials that we found up here. So let's see here, the first one, the partial of f with respect to c at the point 1, 2, 1. Remember, this is cars, trucks, SUV. And that's going to become, if I go to the first one up here, here it is. Cars becomes 1 minus SUV, 1 times trucks, 2. This should be 1 squared. Over trucks, which is 2, times cars squared, 1 squared. And we're going to get, simplify that, we get negative a half. So what does this mean? Well, if we increase our car, if we only have 1 car, 2 trucks, and 1 SUV, and we increase only in the direction of cars, we are going to lose money. So this decreases profit. Therefore, we should decrease the number of cars. Cars aren't selling, maybe. If I look at the change in the profit with respect to trucks, right up here, if we plug this in, we're going to get negative c, which is 1, times s, which is 1, plus t squared, which becomes 4, over truck squared, which is 4, times s, which is 1. And here we're going to get 3/4. So if we look at trucks, trucks is positive. This is greater than 0. Therefore, this will increase profit. Therefore, build more trucks. We want to increase the number of trucks. And the last one, how does the profit, if we only look at SUVs? And this becomes, again, at the point 1, 2, 1. And if I plug that in over here, negative t, so negative 2 times c, which is 1, number of cars, 1, plus s squared, s is 1, so 1 squared, divide that by, s squared c, s, which is 1, squared times c, which is 1, that should be 1 squared, not 12, and that's going to equal negative 1. Therefore, this will decrease profit. What does it mean? Therefore, decrease the number of SUVs. So let's see here. So, number of cars, we set up, we should decrease them. The number of trucks, increase them. And we just said decrease the number of SUVs. So that's saying if we already built 1 car, 2 trucks, SUVs, and we want to increase our profit the most, basically it says build trucks. All right. Hope you guys enjoyed the video. I will see you all later. Bye-bye.